In this video we'll be looking at 6.3, solving systems by elimination using addition and subtraction. So our central question will be, how do I solve systems by using elimination? How do I solve systems by using elimination? So the first thing we'll do is go over the steps that we'll need. Step 1 is write the system vertically. With write the system vertically with like terms aligned. The equations will be, so this is a little side note, equations must be in ax plus by equals c form. And what that is that a is our coefficient in front of x, b is our coefficient in front of y, and c is just a constant. So you want to have the x's and the y's on one side of the equation and the c on the other side of the equation. That way when you stack them, we'll have two equations and we'll have our x's on top of each other and our y's on top of each other. Our next step will be to check to make sure one variable has matching but opposite coefficients. Matching but opposite. So what I mean by that is the same number but opposite numbers. So 4 and -4, or -3/4 and +3/4. So you want to have matching numbers, matching absolute values, but opposite in sign. If not opposite, distribute a -1. We'll do an example that does this so you'll be able to see what I mean by distributed -1. Step 3 will be add the equations together to eliminate one of the variables. And step 4 is kind of this finishing up of the problem, of these system problems, where we will solve for remaining variable, plug back in and solve for other variable. Okay, so let's try this and see what it looks like. And you'll find that while the steps at first kind of look confusing, the process is pretty straightforward, and then we can make sense of these steps. Okay, so I'm going to look at number 1 and try to kind of follow my steps so we can see what's happening. First thing I want to do is write the system vertically with like terms aligned. So what that looks like is I'll take my system, and I can just take, I already have this, so I'll write them vertically. So I have 3x plus 2y equals 17. I'm going to just put this other equation right underneath it. 5x minus 2y equals 7. So I've written them vertically with my like terms. Here are my x's aligned, here are my y's aligned, and here are my constants aligned. So that was step 1. Okay, step 2. Check to make sure one variable has matching but opposite coefficients. So when we look at our x's, they're not matching, so let me move on and see, and hopefully my other variable is matching. They are matching, I both have 2's, and they're opposite. So I'm good to go on that step. We got a yes out of that, so we don't need to distribute the negative 1. Next step we'll do is add. We'll add these together, and one of the variables will eliminate. It will disappear. So let's add going straight down. I have 3x plus 5x is 8x, and then 2y plus a negative 2y, 2y plus negative 2y. That cancels those out. My equal sign comes down, and I have 17 plus 7 is 24. So I've gotten rid of the y's by doing it this way. And now we just solve this equation. I'll divide both sides by 8, and we'll get x equals 3. So I solved for the remaining variable. I'm going to plug that back in and solve for the other variable. You can choose either equation. I'm just going to choose the first one listed, and we'll have 3 times 3 plus 2y equals 17. And now I'm just solving for y, and we get 9 plus 2y equals 17. Subtract 9 from both sides. We'll get 2y equals 8. Divide by 2, and y equals 4. Last thing, write our solution as an ordered pair. X is 3, y is 4, and we're done with the problem. What about that situation where if my coefficients aren't matching and opposite? Well, let's look at that. So on number 2, to make this work out so we can really see it, go ahead and add a negative to that 4x on there. So I just wrote in a negative next to this 4x. Now the first thing we'll want to do is stack them on top of each other. So I have negative 4x minus 3y equals 22. And then my second equation is negative 4x minus 5y equals 26. So as my first step, write them vertically, aligning my like terms. My x's are aligned, my y's are aligned, and my constants are aligned. Now I have matching, they both have 4, they're not opposite. I need them to be matching and opposite. So what we can do is distribute a negative 1. And what that means is I'll multiply everything in one of the equations by negative 1. So when I do this, I will have, this equation will now become 4x plus 3y equals negative 22. And this equation just stays the same. So I'm going to keep it as a negative 4x minus 5y equals 26. Okay, so that's looking pretty good. Now what we'll do is we'll plug our well, now we can follow our steps. We're going to add vertically, combining like terms, and one of my variables will eliminate. So 4x plus negative 4x, those cancel. 3y plus negative 5y would be negative 2y is equal to, then when I add negative 22 and 26 together, I get 4. Now we'll divide both by negative 2, and we'll get y equals negative 2. Now we just plug back in and solve for the other variable. So I'm going to plug in to my first equation, so we have negative 4x minus 3 times, this is me plugging in my negative 2 for y, is equal to 22. All I did is I just grabbed that first equation and I'm plugging in my y and solving for x. Simplifying, we have negative 4x plus 6 equals 22. Subtract 6 from both sides. We'll get negative 4x equals 16. Dividing by negative 4, we get x equals negative 4. So now I need to write my solution as an ordered pair. Negative 4, my x, comma, negative 2, my y, and we're finished that problem. So that's how we can solve systems by using elimination. We're just going to stop here. There's 2 solid examples for you to use. One where we don't have to distribute a negative 1, and this one here, if we want to make that note, this is the distribute a negative distribute a negative 1 example. Thank you for watching, and I hope you have a great rest of your day.